Today we're actually looking at pads and pockets from actual images and placing them on your model or your designs by loading in the image, reading the pixel data and creating geometry in a sketch like this. And here you can see I've just added the pad on here. Now this video is a shorter version to the two other videos that I've got on my site, which explains this more in depth. This one I'll be actually just showing the macro and actually how going through the macro and how to actually create the macro to do this effect. So the macro itself, so if I run through this, first thing we do is we import a library. So the Pi image library here, we're actually importing this image in from the Pi image library, so we're importing this namespace. And we also import the Qt GUI as well from the Pi side. These come packaged with FreeCAD, so you don't have to worry about importing libraries into your file system. They're already there. One is for the actual manipulation of the image, reading data from the image. The other one is to do with the actual FreeCAD GUI itself and not looking up the GUI. Now we need an image, so we're using an image, the C64 logo. Now this is quite a small image. As you can see, there's the image, and if I go to scale image, you can see it's an 80 by 61 pixels. Smaller images, quicker it'll actually take to render, and less processing power we will need to actually convert the image. I advise you to go for black and white images. So with this one, what I'll be doing is working from top to the bottom and traversing from left to right, picking up pixels and looking for color. So now we've got the actual location, we can actually use that image location, which is a variable. Image location that's assigned to that variable is actually used in the image.open, and we pull the result into another variable called img. Now because I pulled that result into img, we've got the size available. Now the size is a tuple. That means that it actually is a collection, and inside that collection it has a zero-based index that we can actually pull values from. Now inside that tuple there's two values. There's the width and the height. So index 0 is the actual width, and then index 1 there's the height. There's more information on the more in-depth videos for this, which I'll add into the show notes, where you can actually go and actually find out about how this all links together. So we pull in the image width and the image height. Now because we need the pixel data, we actually have to run the command load, because this is a lazy load event. So once we actually loaded the actual image and its pixel data into memory, and then we can actually assign the pixel data to another variable. Now running the command get data will actually read across the image and create a linear list of the pixel information. So we won't get a grid, we'll end up with getting a list of values that goes from y0 to the actual height of the image, and then on the x 0 to the width, and it will move across the image, picking up pixels and placing those into a collection known as list. So you'll have a linear list of the pixel data in here rather than a grid. And that's important when we actually go back to actually convert x and y coordinates to an actual index to find the actual pixel data. So after the data is actually pulled into the list, we actually take our first pixel at index 0, which will be this pixel here, and use it as our ignore color. So our ignore color is white. The reason why that's done is because if you're using a grayscale or a black and white image that's only got one channel, then this pixel data will come back as an integer. If you're using a red green blue or a red green blue alpha image, this pixel data will come back as a collection, again a tuple, and it'll have the 3 or the 4 values in there, all indexed 0 red, 1 green, 2 blue and 3 alpha. So that's important when we're actually doing our comparison down here, because if we hard code the actual pixel data in that we want to ignore, depending on what type is pulled back, whether it's tuple or integer, then we're going to have problems with conversion of types. So it's better just to pick up the pixel from the image, therefore we get the actual structure of the type as well. Next we use a pixel spacing. This will be used to actually go across and step with this one 2 pixels. So as we go across, we're actually going across in 2, so every time we go across we're actually missing pixels and just picking up the second pixel. And the reason why is because when we actually start picking up pixel data, A, it's faster because we're only picking out every second pixel, and B, we get a bit of a space between so we can actually create our geometry in our sketch. So if we create a circle every pixel, that will be overlapping and we won't get the effect that we want. If we create it every 4, 8, 2 pixels, and then we get a nice spaced out effect. We also need the size of our geometry, so I'm using 0.5 for the actual radius of the circle that I'm going to use, and that's going to be used in this part here. So you can see the radius of the circle here. This is where we're actually plotting the geometry. So then, once we've got all of this defined, we start getting into our loop. Now the for loop can take up to 3 parameters. So we've got the starting index, the ending index, and the step. So we're using the Y for the Y-axis. So we're going to be going down the image, and we start from 0. So we start from here, and we go to the image height, which is here, and we step by the pixel spacing. So that loop will go down every 2 pixels across the image until it gets to the image height. We just print something on screen to show that we're actually processing the image here, and then we get into our X. So as we're going down, we do the same. We're actually going from 0 to image width to pixel spacing, so the step of pixel spacing, so we're going across the image here. So as we go down 2 pixels, we're actually going and starting to go across. So each time this loops, we get to our next row, and then we read across, next row, read across, next row, read across, all in steps of 2. Now, because we need an index into our list to pick up what pixel information we need to compare with our ignore color, we need to do a bit of maths to figure out whereabouts in the linear list the X and Y pixels, or the X and Y coordinates, actually point to. And that's quite easily done, because if we think about, we have to, each time we go around X, we have to offset by the image width each time. Then that's quite easy to do, because we know we've gone down a row. Then we can use that as a multiplier to create our offset. So for instance, the first time we're in here in Y, we're on row 0. So we get into X, we use the image width, will be the offset, times it by Y. So at the moment, our image width here, say it was 20, we times it by Y, which is 0, so 20 times 0 is 0. We know we need to add 0 to X. So we're starting from 0 index all the way up to 19, so we have got a 20 size image. So 0 to 19, 20 pixels in there. Then next time when we come around, Y is incremented by a pixel spacing of 2, then this will be actually calculated 2 times the image width. So the image width will be now 40, and then we can add that to our X to get our offset. So that will place us in the right place in our list. and we will assign the pixel data from our list at that pixel index. So we're actually using that pixel index to pull out the pixel data from our list and assign it to the pixel. So now we have a pixel in our variable that we can use to compare against our ignore color. Once we compared it against our ignore color, if it doesn't equal the ignore color, then it's got something in there. So we're reading across, we hit this, we do a comparison, and we found something in there. So we now know we've got to plot a piece of geometry at that point. Now to do that, we run this command, and we've got a refresh here as well. Now this command is quite easy to actually pick up. So if I create a new sketch, XY plane, OK, and if I grab one of my panels, the panel I'm looking for is the Python console. So anything I do in here will actually be reflected in here. So if I add a piece of geometry in here, what you can see is that the geometry has been added. So I click on there, you can actually see the X, Y, Z coordinates of the geometry, which relate to here, and also the actual radius of the geometry, 11.35, which relates to here. And you can see there's another command in there because I've just done something to the actual sketch as reflected. So we can actually replace these with X and Y and actually place this with our radius and use this to refresh the screen. So I would copy that, place it in here, and actually add X, Y, and the radius of the circle. Then we use the app recompute, and what I do is use this command here, which allows the GUI to process any information that's outstanding on that thread. Otherwise we actually lock FreeCAD up, and this allows us to actually navigate to our sketch and see what's happening, and what you'll see is those geometry actually appear on screen as this macro is actually running. And last thing we do is actually print a complete to show that we've actually completed. Now all this will actually printing will actually be shown in the report view. So let's get the report view up. And that's the panel's report view. And now if we go back to our unnamed, get rid of that, go back to our macro, hit go, and if I swap over to here, we can see our image is actually starting to appear in our circle geometry. Now we've got a few artifacts here, that's because I haven't removed those from the actual image, but you can see now that's been actually filled in. Obviously I can change the actual size, so let's get rid of that. And I'm going to go for pixel spacing of 4 this time. Radius of the circle is 5, so that gives us more spacing in between. So if you look at this, you can actually see these are quite close together. In our next one, if I run it, you can see our image has been created more quickly. And now we can actually use that to do whatever we want. So what I'm going to show you is actually how to use this in a panel pocket. So if we jump into our part design, and create a body in there, create a sketch, do on the XY plane, OK, and I am going to zoom out, and I'm going to create a square around this, and this is just to get it to the correct dimensions. That's good, close that, and we're just going to give that some padding of 2 millimeters. Now using the page up and page down keys to actually zoom. Trouble is that our sketch is on the bottom at the moment, so we've got to attach that sketch to the face. The first thing we need to do is rename this sketch. So rename the sketch, and we're going to drop it into our body. So now we've dropped it into the body. It will still be on the bottom of the sketch, because what's happened is when the sketch was created, the sketch is placed on the same plane as the other sketch, and we pad up from that sketch. So if you think of the plane goes along here, a padding has gone up, and that sketch is on that bottom as well. So we need to pull this logo onto the top, and that can easily be done by going to your sketch and looking at the map mode. So click on the map mode, click on the three icons on the end. You can see there's no reference selected. So we hit selecting, come over here, and you can see down the bottom left it's got pad face 6, which is the actual pad face that we want to place it on. So we click that pad face, and what should happen is the reference should appear there, but it's come out not attached, so I'm going to hit reference again and select it, and now it's attached itself. So I've got pad face 6 there, and it has moved, but that's okay. So if we press Alt now, just swing this up, you can see the sketch has been moved up off the plane and placed on the same plane as that face. Okay, that. Now we can move this sketch, click on the C64 sketch, and we're looking at attachment. So open up the attachment, open up the position, and we can change the Y position here. So I've just clicked in here, and I'm just using my arrow keys to place it onto position, and the X we can use as well. That all depends on what plane you're actually looking at on. Because I'm on the XY plane, X and Y will be in context, but Z won't, because we don't need the sketch to be moving upwards here. We only use Z if we're on something like the YZ plane. So that's all on there, and now we can actually click on the C64 logo and use one of the paddings or the pocketings to actually produce the effect we want. So I'm going to go for a 2mm pad on there to get that effect. Now I can OK that, or I could go for a pocket, and I'm going to go for a through all to actually go through the whole of the object. You can see the holes in the object. Or we could do a dimension and just set it to 0.5, so it just goes halfway through the actual padding there. Our padding was 2mm, so that's gone quarter way through. So there you go. So you can use that for such things as specific types of ventilation in the shape of logos, or some nice kinds of embellishments on there. So if you look at my channel, you'll find that there's 2 videos regarding this technique, and they go more in depth into how to do the actual programs step by step and what the actual commands mean. It goes more into the Python language and teaching you more about Python rather than reviewing the code as we did here. So I try to do that with my videos. I try with something that's something like coding or scripting. I will actually do an in-depth one. That's over 2 videos. For the people that know about coding or just want to get the macro up and running straight away, they can actually choose the shorter version, which is this one. Please like and subscribe if you enjoyed this, and I'll see you next time. If you like what you're seeing, please subscribe to my site, and also I have a Ko-Fi site where you can actually donate a few pence or a few pounds, dollars, or whatever your currency is, and that's at ko-fi.com/mang0, and there you'll be able to help me fund my site, and all the money that I actually get from any funds will actually get pushed back into the channel. Thanks a lot for watching and subscribing. I'll see you next time.